All right, in this video, we're going to talk about linear regressions, and we're actually going to go in your packet. So I would find this page in the packet. This is your instructions for how to do the linear regression on your calculator. Okay, so we're going to basically read through these instructions. We're going to do two of the problems together. So locate this one, the number of bicycles produced in millions by year. We're going to do that one together. And then we're going to do this linear regression problem, which is average daily energy requirements for male children and adolescents. Okay, and we'll go through all these questions. Okay, so locate those things in your chapter 3 packet. And as we do them, I'm going to walk you through exactly how you do this on your calculator. Okay, so let's go to this one. The table below shows the number of bicycles produced in the United States from 1989 to 1993. Okay? Enter the given data in your calculator and plot the points on a scatter plot. Okay? You might think I don't know how to do that. Well, we're going to follow the directions on here to do that. Okay? So we're going to use this. And when I enter these years, these are huge years. If we want to define our variables as the number of years since the year 0, we could do that. I typically like to make this something that's going to be a little bit easier to set your window in the calculator. You always want to define your variables. So I'm going to call X the number of years. And if we don't want the numbers to be that huge, I'd say let's start at 1980, for instance. You could start at 1900 if you want. You could start at 1985 if you want. But I'm going to say the number of years after or since 1980. Okay, so that means 1989 is 9 years after 1980. So I'm going to enter 9. 1990, I'm going to enter 10. 91, I'm going to enter 11. 92, I'm going to enter 12. 93, I'm going to enter 13. And then the Y is equal to the number of bicycles produced. When you define your variables, you want to define them as specifically and with as much information as possible. So the number of bicycles produced per year. So these are number of bicycles produced in the United States during that year. And this is in millions of bicycles. Okay. And what is the equation of the line of best fit? So now we're going to go to the calculator and we're going to follow these steps. Okay. So here's what your calculator looks like. First thing you're going to go to the home screen, that little home button up there. Okay. And following your instructions on this instruction sheet. Okay. From the home screen, select new document. Okay, we're going to add lists and spreadsheets. Okay, it might have asked you if you wanted to save something. You typically don't want to save your old documents. You don't need them. And then if it says if you're already working within a document, you can add a page. I'll show you how to do that later. But we're just going to, for now, add lists and spreadsheets. At the A and B headings, type in a header name. Okay, so don't type anything here at the equals. That's later on. We're not going to do that today, but later on you can enter formulas in there. But where it says A, B, C, D, you can actually enter how you defined your variables, something that's going to remind you what this means. And this is going to be our X variable, which we said number of years after 1980. You don't want to type all that in. You're just going to put in, let's say, years. So you go down to this touchpad, Y, R, S for years. Or you could spell out years. And then for the Y variable, we said number of bicycles. So I'm just going to type in BIKES. Okay. And you'll see later, these things that you type in here will pop up later on the screen. The calculator is saving that information for you. Okay. So for our X variable, we're going to type in what the values for the different years. And again, we're not typing in 1989 because we defined X as the number of years after 1980. So we have 9, 10, 11, 12, 13. Okay. and hit enter. Ooh, make sure that's right. Hit enter to get off of that, out of that box. Okay, and the number of bicycles produced in millions. Make sure these line up. The 1989 was with the 5.3. We have 6.0, 7.3, 7.4, and 8. Now make sure you don't leave that 8 on the screen with this thing hanging. It doesn't register until you either enter or tab off of that screen. Okay. Now, next thing we're going to do, going back to your instruction sheet. Okay. We entered all the data in there. Now we're going to plot our data. So add another page to your document. The way you do that, you could do Control I, or you can do Control, actually it's Control plus page. So you do Control button, and then you do doc. You can see the blue button behind there, the blue, it says plus page, that adds a page. And you're going to do add data and statistics. Okay. So each one of these dots represents, so this was years 11, 7.3, meaning 11 years after 1980. So that's the year 1991. There were 7.3 million, but we want to graph these or plot these. So it says click to enter variable. You click on there. And what do we want in the x coordinate? We want years. That was our x coordinate. Now we go over here to the y value, the y-axis, and we're going to put the number of bikes up there. Okay, so these are the points we're going to plot. And what we're doing here, we're not going to find a line that fits through every single one of these points, but we want a line of best fit that best represents all of these points. Okay, so the next thing we're going to do, which is down at the bottom of this instruction sheet, you're going to click on menu. You're going to choose 4 to analyze. And we're going to go down to number 6 for regression. And we're just going to do the first one. We're going to get an equation in the form y equals mx plus b. Okay. All those other options are what you would use in a statistics course. Okay. And there's our equation. So now we've got the equation. Now we really have everything that we need. I'm going to show you a few neat things you can do on the calculator later. But let's go back to the paper. Let's start answering some of these questions. Okay, so what is the equation of your line of best fit? Let's write it down. It was y equals 0.68x minus 0.68. Okay. Now, it says, use this line to predict the number of bicycles produced in 2009. So we're finding number of bicycles. We're finding the y value when x is 2009, or really x in 2009, that means x is, well, how many years after 1980 is that? That would be 29 years. Okay, so we're finding the y value, 0.68x, but let's plug in the x. So we're plugging in 29 for x, then minus 0.68. And you can plug that in on the calculator. You can simply, I'll show you a couple ways to do that. We could make a new page. Let's make a new page. So to add a page, we're going to do Control Doc to add a new page. Let's just do a calculator page. And we can just type in 0.68 times 29 minus 0.68. Enter. 19.04. So we get 19.04 million bicycles produced. Okay, so basically what we're doing is we're predicting, we're using this model to predict how many bicycles we're going to have in that year. What did I do wrong? 0.68 times, oh yeah, 2009 Okay. Okay, so that's our prediction. When will there be 50 million? Now, this is a little bit trickier because now we're solving for x when the y value is 50. So we're going to plug in 50 for y equals 0.68 times x minus 0.68. So solving that, we're going to add the 0.68 to both sides and then divide by this 0.68. So we could type that in here. So 50 plus 0.68 equals, and then we're going to divide by 0.68 and hit enter, and we get 74. So x equals 74.5294. Remember, that's the number of years after 1980. So if we add that to 1980, our year is going to be 2054, about midway through the year, 0.5. Okay. Now, I want to show you one more feature on the calculator, and this is a solve feature. So we can solve this equation for either variable. Okay. So if we go to menu and we go to algebra and you go to solve. Okay, so this lets you solve any equation. So we're going to solve, let's just do part B. So we're going to solve y equals, so you go y equals 0.68x. Actually, let's put in, 0.68x plus or minus 0.68. And I can actually, what I can do is I can put in, we want to put in the value 29. So times 29. Okay. We're solving this equation. So you put in a comma. Comma is over here next to the, where's the comma? Down here. Down here, all the way at the bottom left. And we're solving this one for y. Okay. Hit enter, and we get 19.04, which is what we got. Okay, that doesn't seem real convenient because really what we didn't really do anything special. But let me go back and show you what happens. So another thing you can do, you can just arrow up. Notice I'm just arrowing up to this, and you hit enter, and it brings it down. So now if we want to solve for the y value, so let's go back and replace that with an x. Now our solve for the x value. And we're going to plug in our y value in part C. We wanted that to be 50. Okay, so now we're solving the equation 50 equals 0.68x minus 0.68. And now we're going to solve this equation. Instead of putting comma y, you're going to put comma x because we want to solve for x. So it's funny, I'm solving this equation, I'm solving it for x. And we get 74.5294. Okay, so that's something that's kind of neat for the calculator, that it can solve any kind of equation, no matter how complicated the equation is. And even if you have other variables in there, it would solve this equation for whatever variable you put over here after the comma. Okay. Now let's do the last part of this question. Okay. Use the solve feature. Set equation equal to 0 to use the solver to find x. Oh, we could do that. We could have set equation. I would just do it the way that we did it. Okay. Now give the meaning of the slope in context. Okay. Let's first find the units of the slope. Find units of the slope. And then I want to find the meaning of the slope in context. So the units are, remember what slope is. It's change in y over change in x. So delta y over delta x. Okay. And what's our units of our y variable? It's a number of bicycles. And the change in x, well, the change in x is number of years. So our units for the slope are number of bicycles per year. Number of bicycles per year. Okay, that's the units of the slope. Now, what is the meaning of the slope? Okay, in context, well, our slope was 0.68. Okay, now be careful because it doesn't mean there are 0.68 million bicycles produced per year. There's way more than that produced per year. 0.68 isn't the number, it's the change in y over the change in x. So the number of bicycles, the change in number of bicycles per year is 0.68. And 0.68 million is 680,000. Okay, so the meaning of the slope in context is the number of bicycles produced per year is increasing at a rate of 680,000 bicycles per year. Okay, so that's how many additional bicycles are being produced. Oh, you can't see that. The number of bicycles produced per year is increasing at a rate of 680,000 bicycles per year. That's how much it's increasing by. So if you look at the numbers up here, that kind of makes sense. In the year from 89 to 90, they went up by 700,000. 90 to 91, they went up by 1.3 million. 91 to 92, they only went up by 100,000. And then 92 to 93, they went up by 600,000. Okay, so overall, the slope or the increase in number of bicycles per year is 680,000 per year. So that's really important. Okay, let's look at the next one, and we can do this one a little bit faster. The table below shows the average daily energy requirements for male children and adolescents. Okay. So at age 1, you need 1,100. At age 2, you need 1,300. Age 5, you need 1,800, and so on. By age 17, you need 3,000 for the average male growing up. And make a scatter plot of your data. Okay, let's go and do this. We're going to do this fairly quickly. I'm just going to start over. Go here, new document. You don't need to save that. We're going to go to lists and spreadsheets. Okay. And the year, the age. So I'm going to just type in age up here. And remember, you're putting it up here at the top. And then over here, we've got number of calories. So I'm just going to type in cal. The reason is because when you make that scatter plot, and you want to put the correct variable in the x-axis and y-axis, those are what are going to pop up in the drop-down menu. Okay, so your age is 1, 2, 5, 8, 11, 14, and 17. Right. And the number of calories, when you're 1, you need 1,100, 1,300, 1,800, 200, 2,500, 800, and 3,000. Okay. I always like to double check. If even one number is off, it's going to completely mess up your equation. So just make sure you type those all in correctly. Okay. Now we're going to add a page. So Control plus page or Control doc. And we're going to add data and statistics. Here's our data points we just entered. On the x-axis, we want age. And on the y-axis, we want calories. Okay, and if you forget exactly how to do this, you can look at your instruction sheet. We've got menu, analyze, we want regression, and we want the linear regression y equals mx plus b. So there's our equation. I can write that down. Okay. go to, I've got y equals 119.401x plus 1110.68. Okay. And let's see. Okay. And there's our equation. So let's just type in this equation and let's answer these questions. We made our scatter plot. Let's define our variables. It didn't specifically ask us to do that, but it is always a good idea to do that. So X is age in years of a male youth. I'll just say youth. And Y equals number of calories. These are daily calories required per day. The number of calories required per day. And what is the vertical, the y-intercept? Remember what the y-intercept is. The y-intercept is the y value when x is 0. Okay. So what is the y value when x is 0? What is it? Well, let's find out. Let's plug in 0 for y and find the x value. Okay. So we would use our equation. And we've got, we're plugging in 0 for x and finding the y value. Okay. So y equals 119.401 times 0 plus 1110.68. So 1110.68, y-intercept is 1110.68. And what does that mean? That means at age 0, so when x is 0, at birth, a male infant requires 1110.68 calories per day. Okay. And use your equation to estimate the daily energy requirements for a 16-year-old. So we're going to plug in 16 for x. Okay. We've got y equals 119.401 times 16 plus 1110.68. And then how old is a male who requires 2450? Well, 2450 is your number of calories, which is the y. Times x plus 1110.68. Okay. And let's plug these in. Let's go to our calculator. I'm just going to add a page. Add a calculator page. And let's use the solve again just to get practice using that. So we're going to go menu, algebra, solve. And we're solving the equation. Y equals. You know what we can do here, which is nice to get more exact? You actually don't have to enter that 119.401. You can enter the var button over here. So enter the var button, and it stores that for you. It stores the slope as your stat m. So this thing, make sure you use the times button here. Okay, otherwise it reads that together as a different word. So times your 16 or times your x value. Okay, I'm just going to put in the x for now. Plus We've got the plus button, and then we've got that 1110.68, but you know what? Maybe that's not exact. So I'm going to go to the var, and that's actually my y-intercept. So it's you put in what it calculated, the statistics calculated for your b value. In this equation, we're solving, so I'm going to put in the comma, again, the comma's down the bottom left, and we're solving this for y. Okay, now notice there's two unknowns here. So if we solve this for y, it leaves x in the equation. Now we're going to solve it for y when x is 16. Okay, so instead of times x there, I'm going to do times 16. And our y value is 3,021. So a 16-year-old is estimated to need 3,021.09 calories per day. Okay. And let's go to, actually, let's see. I think that you can do menu. Let's go to doc and settings. If we want to be more accurate, let's go to doc. Get out of there, hold on. Let's go to doc, settings, number 7. And that's not what I want. Let's go to doc. Let's go to settings. And I want document settings. Okay. So float 6, it's giving me 6 decimal places. Maybe we want more. Actually, maybe that's enough. Maybe it's actually giving us plenty. And hit OK. Okay, it's only giving us 2. So that must be exact. What if we asked it doc settings? Okay, that's not what I want. Doc. Sometimes it's better to hit the number. So settings, hit 7. Document settings, just hit the number 2. And display digits. Let's do, instead of float, let's do fixed. This way I want 8 decimal places. Then you know it's exact. This is just something you can play with. And I'm going to go up and I'm going to do that again. Now it's going to give me more decimal places. Okay, so I can be a little bit more accurate when you're required. And the nice thing, again, when you put in this M and this B from the calculator, it's keeping not just 2 decimal places or 8 decimal places. It's keeping everything that it has stored in the calculator. Okay. Now, for part E, we're going to solve for how old is a man who requires 2450 calories per day. Okay, so I'm going to arrow up and I'm going to grab that again so I don't have to retype everything. Okay, but this time I'm going to solve for x. So change that to an x. And we know the y here. We know the y is 2450. And here I'm going to put in the x. Okay, so y equals mx plus b. Okay, but we plugged in this for y, we're solving for x, and hit enter, and it gives us all this. Okay, so that's 11.217. I think that's enough. This other one was 3021.0937. How about 0.094? Okay, so going back to this, you can put these numbers in here, you can get as accurate as you want. So I'm showing a bunch of different things with the calculator and settings and different things. Okay, do you think your model also applies to adult males? So this is assuming that the number of calories that you need is a linear function. So let's go back to our equation. Let's look at it. You can go back to these other pages by just clicking on them. Do you think it's going to keep increasing at the same rate until you're 40 years old, 50 years old, 70 years old? Probably not. It's probably going to level off at some point. Okay. So do you think your model also applies to adult males? Well, let's figure out how we want to write this out. I would say probably not. Okay, because, let's just give an example. Because then a 40-year-old male would require You can plug in 40 years old in for X and solve for Y, and you would get 5,886.72 calories per day. And that is a lot. Okay. The issue is that you need more and more calories as you grow up because you're growing. But once you stop growing, the amount of calories that you need doesn't increase in the same way. Okay. Furthermore, a 70-year-old, I actually typed this in just for fun, 7-year-old would require 9,468.75 calories per day. Okay. Yowza, that's a lot of calories. Okay. So the final thing that I want to do is talk about the slope. Okay. What are the units of the slope? Let's just go up here, and we've got some room up here. Units of the slope. Remember, slope is your change in y over change in x. So units of the slope are in calories per year. Calories per year. And what is the meaning of the slope in context? So the meaning of the slope in context, okay, is it the number of calories required per year? Notice your slope is 119.4. So nobody only requires that much. It's the change. It's the change in number of calories per year. So what it means is that probably from the ages, we'll just say from the ages of 1 to 17, we'll say the number of calories per year required is increasing. Oh gosh, okay, I'm going to go down here and finish. Is increasing at a rate of 119.4 calories per year. Okay, so that's important. So the units of the slope are calories per year. The meaning of the slope in the context of the problem, and when it says in the context of the problem, definitely use that number that's the slope and explain what it means. From ages 1 to 17, the number of calories per year required is increasing at a rate of 119.4 calories per year. Looks like from age 1 to 2, it increases about 200. From 2 to 5, well, you'd have to take 500 and divide it by 3 to figure out how many calories per year that's increasing, and so on. But overall, from these ages, your rate of increase of number of calories needed per year is this. And that's why if that kept increasing at that rate, by the time you're 70 years old, you would need this many calories. You'd be eating all day long. All right, that's it for today.